Hey folks, welcome back for another episode of Code Club. In today's episode, I am going to show you how you can put a break in the x-axis using ggplot2 and other goodies from R and the tidyverse. If you go back to September 27th in my newsletter, you will find that I kind of verbally went through a description of how I would go about doing this. If you are not subscribed to my newsletter, by all means, please go down below in the description of this video. You will find a link there to get to that post from back in September, as well as information or a link to show you how you can subscribe to the newsletter. That newsletter, I picked on one figure from this paper, pre-existing cell state rather than stochastic noise confers high or low infection susceptibility of human lung epithelial cells to adenovirus. It was published in the journal M-Sphere, and the first author was Anthony Pedkidis. I'm sure I'm butchering that, as I always do when I bring up these papers. I picked the paper for the figures, not for the pronunciation of the last names of the authors. Anyway, so if you go to their figure 3 in this paper, and specifically panels E and F, what you'll find is something that I find to be very common when looking at figures in the scientific literature. Each week when I kind of go through and try to find a different figure to present, I will frequently find a break in either the x-axis, as these two panels show, or a break in the y-axis. Now, you should know that putting a break in the axis like this is generally considered a bad habit, a bad practice in data visualization. And I won't get into that now. Maybe I'll do that for the Thursday episode. But what I wanted to do is show you how you might go about doing this. Again, I don't think you should do it, but you might be wondering, well, how would you do it, right? Because that might be a skill that could translate to other applications. I don't know what those might be, but again, it allows us to practice using our skills from ggplot2, the tidyverse, and other things in R. Just kind of a brief description of what's going on here, where they're looking at correlation coefficients within 3 levels of variation. So the first that I'll call your attention to is a random permutation, where I think they're looking kind of randomly permuting across all weeks in this experiment and looking at the mean or median Spearman R value, as well as the 95% confidence interval. Each of the experiments that they performed on each week, they had 18 replicates. They then had in gray the technical variation. So if you look within a week, how much variation is there is with the gray showing. And then the blue is the biological variation, comparing what happened in week 1 back to week 0, week 2 back to week 1, and so forth. And so I think what they kind of show is that over the first 4 or 5 weeks, things biologically stabilize. But when they go out to 8 or 9 weeks, things get a bit more messy. All right. So I'm not really wanting to dig into the science. I don't understand the science well myself. What I want to think about is how we would go about generating this figure. Here in RStudio, I have created some example code that we can play with. It's not the exact code that they used, but it's my best attempt to kind of replicate the general principles of what they were looking at. If you want to get this code, as well as all of the code that I'm generating in today's episode, down below in the description for this episode is a link to the blog post that goes with this episode, and you can go there and get the code. One thing to note is that for their biological replication, that was this blue, that they have 18 replicates per time point. And for the technical and random variation, they had 108 replicates per week. Okay. And so again, if you use my set seed value of 1976-0620, we should all be on the same page and get roughly the same results. Actually, we should get exactly the same results. There might be a little bit of difference between like a Mac and Windows, but I don't think so. So again, if we look at eData, we get a 3-column tibble with the condition, the week, and the Spearman. So let's start out by creating a dot plot or a scatter plot of the data. So we can do ggplot, AES. On the x-axis, we're going to want the week. The y, we're going to want Spearman. And then the color, we're going to want condition. And we can then add to that geom point. Oh, and I forgot to add the data. Silly me. eData, pipe that in. There we go. Now we have all of our data over in the right side plotting window. And again, green is the random, where we had the largest variation. The blue is the technical, and then the red is the biological. Okay. And so one of the problems we see right off the bat is beyond just all the data showing up, is that the data is falling on top of each other. It's overlapping. We're going to do something different than geom point, but just to kind of show you how we might deal with this would be to use position equals position dodge, and then give that a width, and let's say 0.5. And so now you can see that the points no longer overlap on each other like these red and green or the red and blue, okay? But again, the bigger problem is that there's 108 points here in the green technical for week 2, right? And so we want to get rid of that. And of course, we also have this gap in the data, which I don't think is a huge gap, but the authors that made this figure went ahead and they broke the axis so that there wouldn't be such a big gap. And so those are the two big things that we're going to take on today. So first, let's go about summarizing the data. Now, what I would often do would be to take eData and make a second data frame that has my summarization information, right? Like my mean and my 95% confidence interval, all right? But we don't have to do that. There's a handy function called stat_summary. And so stat_summary will take the data within each grouping and summarize it. The output we get is a circle for each week and condition with a bit of a line indicating the error bar. And we're told down below that no summary function was supplied, defaulting to mean_se. So this is the mean plus or minus one standard error. There's a variety of different functions that we can use to summarize the data. And so if we do stat summary, we get the help page, and we see that there's a function for fun data. So the function to summarize the data, which will return a maximum value, a middle, like a mean value or a median, as well as the minimum value. Alternatively, you can specify 3 separate functions for those different things. There's an argument that allows you to give arguments to these different functions, right? And then there's a variety of other things in here as well. And looking down at the examples, I find to be a good place to get an idea of the types of functions that I might want to use to summarize my data. And so the one that I'm going to be interested in is this mean CL boot. And so that's going to give us the mean with a confidence interval that is indicating the 95% confidence interval using a bootstrapping procedure. So if I do mean CL boot, so we see mean CL boot, which is what I got here looking for. There's also an mean CL normal, and then an SDL, and then median high-low. So let's go ahead and look at these. I think they're all going to take us to the same function, right? And so there's mean CL normal, mean SD, SDL, and then CL boot for the mean, and then a median high-low. I think what I'm actually going to perhaps use is this median high-low, because this will give me the median plus use the data to generate the confidence interval. So in here, we can then do fun.data equals median underscore high-low. This then gives us our 95% confidence interval, and our data isn't exactly pegged to 0 like we saw in the original here. These all have a value of 0, but we generally have the same kind of gist of what's going on. And of course, there's things we're going to want to change. So for example, I see that the data are not dodged with each other, but we'll worry about that soon enough. But overall, I think it looks pretty good. So the first thing that I'm going to do is change the fill color to be different than the border of my circle. One thing I notice about their plotting symbol is that they're using a symbol like 21, right? Where you have a circle where you can change the outside color, but the whiskers are the same color as the fill, right? And so that's a little bit different than how we might do things within ggplot2. Also, I notice that the whiskers for the random permutation data are black rather than the color. So let's start by trying to make our plotting symbols look like they do for biological variability and technical variability, and then we'll come back and see if we can do something special for random permutation. Let's start by seeing if we can do shape equals 21, and so that gets us the circular plotting symbol with an empty fill. And so let's go ahead in here and then do fill equals condition. So now it looks like a solid circle. That's not exactly what we want. And if we did color equals black, that's then going to make the border black as well as the extensions. Okay. So I think I'm going to end up doing the lines separate from the point because ultimately I want a little cap on those confidence intervals to match what they have here in the original figure. So let's go ahead and copy this and we'll put in that plus sign. And for the first, we'll do geom equals error bar. And let's go ahead and we can remove this shape and the color. For the second one, we'll do geom equals point. And here we'll do shape equals 21, color equals black for the border of the plotting symbol. So now what we get is to match effectively what we have for the biological variation points as well as the technical variation points. Of course, the colors are a bit different. One other thing is that theirs are dodged, ours are not dodged yet. So let's go ahead in here and we can then do position equals position dodge. And we'll do width equals, let's say 0.5. And then we'll copy that down here to do the same thing for our error bar. And so now we can see that the data are dodged a bit. Their plot was wider than it was tall. So I'm going to go ahead and save this out to a file. So we'll do ggsave, and I'll do broken x-axis.png. We'll do width equals 6, height equals 4. Pretty good start for us. I'm noticing that the whiskers kind of overlap with each other a bit. So let's make the width of those whiskers a little bit shorter. And so that was up here with this first one with the error bar. We'll do width equals 0.2. Okay, maybe that's a little bit too narrow. Let's do width equals 0.4. Okay, I think that looks pretty good. And I don't think that the whiskers overlap each other too horribly bad at this point. I think that looks pretty good. Now let's think about matching those colors. We'll do scale, color, manual, and we'll do breaks equals with the C, and we're gonna have those three conditions, right? Technical, random, biological. So we'll do technical, biological, random, and then we'll do values. And so these then are going to be the colors that we want. And so I'm going to go with, I'm going to call that brick, Dodger blue, and dark gray. Doesn't come up anything. Brick 1, no. Okay, let's just do dark red. I think that's fine. And then for technical, it was gray. And then for biological, we'll do Dodger blue. And maybe gray will make dark gray. Yeah, that's cool. And then our dark red here needs an opening quote mark. Good. Cool. So that's the color. I think those colors are decent. Now what we want to do is the same thing, but for scale fill manual. So we'll do fill manual, and I think I forgot a plus sign over here. And so now we have our black border with our colored fill and whiskers. So I think that looks pretty good. Let's go ahead and get the names right. So here in scale color manual, scale fill manual, we could do labels equals, we'll do technical variability, and then biological variability, and then random permutation. And so now we've got our three titles, but because our scales differed in the labels, then we get two different legends. So we will come back and go ahead and copy down this labels and paste that in, remove that plus sign. That looks good. Theirs doesn't have a title for the condition. So I'm going to do that in the labs function because we're going to have to change the labels anyway. And so we'll do color equals null, fill equals null. Very good. That got rid of the title, the condition title for our legend. The next thing that we want to do is go ahead and modify our X and Y axis labels. They had time in weeks and Spearman R on the Y axis. So for X, we'll do time weeks, and theirs was all lowercase, and the Y was Spearman R. Let's go ahead and move the legend to the bottom, and we can do that with theme, and we'll do legend dot position equals bottom, and so that puts the legend, of course, at the bottom. I'm not totally sure if theirs was centered or left justified because theirs starts all the way over at the left. Let's go ahead and left justify it. So we can then do legend dot justification, and we'll do left. And so that moves it to the left. One thing that I'm noticing is that we have a line through our plotting symbols, whereas theirs didn't. And so we can get rid of that by going up to our stat summary with the error bar, and we can then do show.legend equals false. And so that should remove the error bar part of the legend, but not the point part of the legend. And so sure enough, that got rid of that. Of course, we're also seeing this gray background for all of our plotting symbols, as well as for the overall figure. If we come back here, we see something that looks a lot more like theme classic. So let's add theme classic. So we want to add theme classic before the theme. So the theme classic. So that looks really nice. One thing I'm noticing with the legend is that theirs, I believe, went biological, technical, random. So let's go ahead and reorder that. And we can do that with factors by coming back up here to our eData. And let's go ahead and mutate condition to be a factor. And we'll then make it a factor condition. And our levels we'll put in as biological, technical, random. And then let's pipe that in, and we'll go ahead and put this on separate lines so everything looks good. And this ggplot, okay. Uh-oh, so something's wrong. I only have the biological. Let's see. I must have misspelled it. Yep, technical, and then random has a space. So if you give levels that don't match the actual values in the vector, then you'll get nothing back. And so I had 2 of 3 things being misspelled. Go me. All right, there we now have the technical variability, biological variability, and the random permutation. We've seen this in previous episodes that we can kind of remove some of that space by changing the size of the scale. And so we can do legend.key.size. And so we can give that a unit function. We'll do 8pt. So that brings everything in closer together. But the problem I'm having is that the space here on either side of the symbol is the same, right? So let's do legend.key.spacing. In the x-axis, we'll again do unit, and let's do 8pt. And that gets us more spacing between the two. So I'm going to make the space between the point and the text a little bit smaller, and between the previous text and the new point a little bit wider. Good. I think that gives us some pretty nice separation of those different values. And now we're in good shape. So now what we're excited to do is to look at our x-axis and think about how we can put a break in this x-axis. One thing I notice off the bat is that this is showing the data in a continuous scale, right? It's going 0, 2.5, 5, 7.5, 10 weeks, rather than showing it at kind of like the specified breaks. And we could do that with scale x discrete or scale x continuous, right? We could put in those actual labels. And so let's see how we might do that. Let's go ahead and do that. So we'll come in here and we'll do scale x continuous, and we'll do breaks equals c 0, 1, 2, 3, 4, and then we'll also do 8 and 9, and then we'll do the same labels on that, and then we'll replace breaks with labels. Oh, and I think I forgot a plus sign here. Now everything's labeled correctly, but we have this big space. So my strategy for getting rid of this big space is to convert everything from being a continuous variable, a double or an integer, and turn it into a character. And in that case, then it will treat the x-axis as a discrete scale rather than a continuous scale. So let's see how we might do that. For now, I'm going to go ahead and comment out my scale x continuous. So let's come back up here to our mutate, and we'll do week equals as.character on week. And so again, that's going to take the week as a numerical column and turn it into a character column. And so now what we see is that we have our weeks evenly spaced across the x-axis, but we don't have a break in here. So what I'd like to do is add a week. I'm going to add a week 5 in here. And then what we'll do is we'll basically erase the label for that week, right? And so let's then think about how we might do that. So I'm going to bind to this a small data frame. So I'll then do bind rows, and we'll do x equals 5 for week 5. And then we'll do condition, and then we'll have these 3 levels, right? And maybe I'll put these on separate lines so I can kind of think about what this data frame is going to look like. And then we're going to have Spearman, and I'm going to put it in the middle of the plot, like at 0, just to make sure everything works. So this is my tibble. Oh, I got to say it's a tibble, right? All right. Tibble on that. And clean this all up. And then we need a closing parentheses here. So it's weird I'm getting this NA out here. Not totally sure what that's about, except, oh, I put x equals 5 rather than week equals 5. I think I was just thinking about ggplot and mapping things. So let's do week equals 5. So now what we have is week equals 5 right here in the middle. All right. Now what I'm going to do is I'm going to move these 3 points down. I want to see actually if I can move them outside of the plotting range. So what I'm going to do is I'm going to make this Spearman -1 to make sure that it's well below my plot. And so now it's down here, but I want this to be kind of the bottom edge at about like -0.6. So let's go ahead and do that in chord Cartesian. And so I'll do that here. So we'll do chord Cartesian, and then we'll do ylim equals from -0.6 to 1.0, and then add a plus here. And so that hides our data and leaves that 5 there, right? So let's go ahead now and change our label on that x-axis. So again, we'll come back up here to where we had scale x continuous, and we'll make this scale x discrete. And let's add a break of 5 and a label of 5. All right, so now we've got that label in there, but let's go ahead and remove the label. And so again, these are all going to be text. And so now we've removed that label at 5. Now what I want to do is I'm going to add a segment using annotate to cover this part of the line, as well as hopefully that tick mark. And so let's go ahead and do that with annotate. And so I'll come back up here to below my stat summary, and I'll do annotate. So we'll start with segment to tell it the geom we want. And we need an x end, a y, and a y end. And so for x, let's go ahead and make that 4.5. Our x end, let's make that 5.5. Our y, that's going to be negative 0.6. And then our y end will be the same thing. And I'm going to make this red so it's easy to spot. And then we'll do line width equals 3. Make sure we got a plus sign there. So it's complaining about an unknown aesthetic xmin. I don't know what that is because I don't have an xmin in here. But what I am seeing is that I kind of missed, right? I need this to be 4.5 to 5.5. I forgot to include the 0. That is called a fence post error. So we'll make this 5.5 to 6.5. Okay, so that positions it in the right place. For some reason, the color is not coming up as red. Oh, that must be the xmin. We'll do color equals red. Now the error message goes away, and we've got that in the right place. It's positioned correctly on the x-axis, but not on the y. So my y, I did -0.6 to 1. So I'm going to go ahead and turn off the expand. So I'll do expand equals false. And so this should remove the padding around the plot. And now this puts my red line right up against the axis. So I can see the rest of the line if I come back into chord Cartesian and then do clip equals off. And so now what I see is my red line is actually under the axis line, and I'm seeing those 3 points way down here, which I want them out of the way. So let's go ahead and remove those further down before we go any further. And so I'll make that -2. So now those points are well below the plot. I don't need to worry about them. But the problem I'm having is that my line is under the axis line. And we've actually seen this in previous episodes. The one that I made was like the 1D scatter plot. We had a whole bunch of points over here, and I actually wanted those points to fall on top of the y-axis. Do you remember what we did to get that to work? Actually, what we did was we removed the y-axis, and we then manually drew in a y-axis. So I think that's the strategy we'll have to do instead of annotate. So let's go ahead and modify this, where we, again, come back up here to our annotate, and I'm going to go from 0.5 to 5.5. I'm going to make this a vector, actually. So we'll do 0.5 to 5.5, and then 6.5, and then, let's see, 5.5 to 9.5. All right, so that looks pretty good. Some things that we might want to fiddle with a bit is that I think I went way beyond where I wanted to be here. So let's come back up to my annotation, make that 8.5. All right, so that looks better. I think I probably went too far to the left here. So let's maybe tighten it up a little bit, and I'll make that 0.75, and maybe I'll go ahead and make this 8.25. So I think that looks pretty good. We're going to want this axis to be gone, and let's go ahead and remove that axis and the tick marks. So we'll now do axis.line.x equals element blank. And we'll also want to do axis.ticks .x equals element blank. So that all goes away, good. But we do want tick marks on the x-axis. So we'll do that with annotate again, right? All this fun with annotate. And so now what we'll do is we'll put these at, where? We're going to put these at 1, 2, 3, 4, 5. We're going to skip 6, and we'll do 7 and 8. 7 and 8. And then it'll be the same value for x end, because instead of drawing a horizontal line, now we're going to draw a vertical line. Okay. And so here then at y, we'll start at negative 0.6, and y end, let's put down to negative 0.65. And let me go ahead and clean some of this up so it doesn't go off the screen. And so now what we have is a really thick red line with tick marks, right? But we've got that break. So let's go ahead and fix that here in annotate. We'll make our color black. Our line width, I think, is 0.5 is the default. We'll do the same thing here, and 0.5. And that looks pretty good. So I think the longer tick mark actually matches the longer tick mark on their plot, but we have to duplicate it on the y-axis. We also have to then move our labels down a smidge. So let's go ahead and then do axis.text. We'll do element text, and then we'll do margin equals margin, and then the top margin, let's make that, let's try 5. That's better. Let's go a smidge more. So maybe we'll make this 7. That's great. Now we want to make the lines, the tick marks on the y-axis, a little bit longer. So then we'll do axis.ticks.length.y. And this is then going to be a unit. So we'll do a unit, and I'll say 7. And then I think the unit will be PT. So those two should match. Cool. I think those do match. They look really good. All right. So the next thing we want to do is draw in kind of the diagonal hashed lines. And I'm thinking this is kind of a big break between the two parts of the axis. So let's go ahead and lengthen our lines just a bit. So let's have it end at 5.75 and start up again at 6.25. And so I think that's a pretty nice size break that we have there. And now we need to get kind of those diagonal lines, and we'll use annotate to do that as well. And so again, all this fun stuff with annotate. Let's do annotate with segment, and then we'll need an x end, a y end, and then, yeah, I think that'll be it. And so our x is going to go, so the opening is from 6.2, so our opening is from 5.75 to 6.25. So if we do x equals 5.75, and we make our end equal the same thing, and our y, let's have that be kind of the same height as our tick marks, right? So our tick marks were 0.05. So we'll go from negative 0.55 to negative 0.65. And so there's a break, but we'd like it at a bit of a diagonal. And so we're going to move the one x in and the other x out. So let's think about where things start and end. So 5.75 negative 0.55. So this is the top edge of the diagonal. So let's move this over to say 6, and then move this over to 5.5. Okay, that's a pretty big diagonal. Let's back that off a bit. So let's go ahead and make this 5.85, and we'll make this 5.65. So I think that's a pretty good angle. We can, again, duplicate that for the second part of the line, right? And so we'll go ahead and make this a series of vectors. Again, you can do this with separate annotate functions. I'm doing it with these vectors so that I just kind of keep things perhaps a little bit more compact. And then we'll do the same thing here for y end. All right, so now we need to draw in the second diagonal. So again, before it ended at 5.7, so the first diagonal met the point at 5.75, and the second is going to pick up at 6.25. So again, what we did before was like 6.25, 6.25, and then we're going to basically have the same y values, and then negative 0.65. And so again, that gets us our vertical line, and we're going to then bump it by the same amount that we bumped before, which was 1/10 in either direction. So we'll make this one 6.35 and this one 6.15. There we go. We now have our break in the x-axis. So I think this break looks pretty good. Again, this break isn't something that I would do for my own data, I don't think. But at the same time, going through the practice of putting a break in has helped me to see a variety of different elements in making a plot. One other thing I wouldn't do would be to make the error bars for the random permutation black and everything else being the color of the fill. All right, so one final thing that I'm noticing, of course, is that I have my variables are out of order. I don't know how that happened or if I actually ever had it in the correct order. Let's check back up here with the factor. I see my levels are biological, technical, and random. But down here, I have technical, biological, random. So I'm going to flip these real quick, and I'll show you what I've got when I'm done. All right, so again, I got the order right in my scale color manual and scale fill manual, and now I've got the right order here as well. And on the whole, I'm pretty happy with the way this turned out. I think I did a pretty good job of replicating what they had in the original figure here. There's probably a variety of things that you could poke and play with a bit, maybe make the plotting symbol a little bit bigger. But on the whole, I'm pretty happy with the way this looked. Again, the two major things that I wanted to focus on in this episode was using stat summary, and then the other thing was putting a break in the x-axis. You could do the same type of thing on the y-axis if you were so inclined. Again, this is not the way that I would depict the data if it were my own. I'm not a fan of the broken axis. If you have a jump in the weeks like they did here, or sometimes on the y-axis, one group will be much larger than the other groups. There are other strategies that one could use. And so I think in the next episode, we'll begin playing with those other strategies that are, I think, and other people have said they think, are preferable to a break in an x-axis. Again, there are packages to do this. One of the things that I tell people is that ggplot2 is what they call opinionated. And so there are certain practices that they encourage people to do and they discourage people from doing. And so if something is hard to do, then they're discouraging you from doing that. So if making a break in the x or y axis is hard, maybe you should rethink whether or not you really want to put a break in the x or y axis. So again, I'll talk about other strategies in the next episode. Until then, please tell your friends about what we're doing here on Code Club. Make sure that you're all subscribed, and I'll see you next time.